Hello everyone, welcome to the session. Just give me 1 second, let me check if I'm online. Alright, let's begin. So today we're going to learn more about more than errors. What we're going to learn in today's class is how to eliminate errors. Alright, so once again before we begin, my name is Mohana. I'm a physics educator here with Unacademy. I have my master's degree in physics and I'm a plus verified educator. So you can follow me through my Telegram channel, or you can also follow the ICSE and ISE board common Telegram channel as well. Alright, so with this note, let's begin. So what normally do we call as error? For example, let's say every manufacturers, right, before they let's say a pencil is being manufactured, so they would have a certain diameter or they would have a certain thickness that is standard for this pencil, right, depending on the company to company. So that standard value they have for every pencil, or for example in this case, let's say the thickness of this particular pencil, or in other words the diameter again, okay, let me give that with the letter T. Let's say that's somewhere around 3.50, okay, somewhere around this is a very huge number. Just give me 1 second. Let's go with 1.5. okay, somewhere around 1.5 centimeters. Now what we are going to do is we are going to try and measure this particular thickness of the pencil. Let's say we are going to use, you can use a 1A caliper because we just want only up to 2 decimal place values, right? So let's say we are using a 1A caliper to measure, and we are finding the measured value, right? When we measured the thickness, okay, this is from our value, let's write it as T dash, we end up finding it to be 1.49 centimeters. Okay, what is the difference between these two values? Somewhere around 0.01 centimeters. This value is actually the error, right? So error is nothing but what is the actual value, right? Error in any measurement, if you take, error is nothing but, okay, the difference between what is the true value, what is basically the true value of this particular object, okay, true value minus what was the measured value we got. This is basically error. Okay, yes Akshay, thank you for that answer. Alright, now when you look at errors, there are different types of errors. You can go generally when you look at gross errors, this come into picture because of a person's carelessness, okay. And again, if you look at random error, for example, let's say we are measuring the diameter of this pencil, and let's say at one reading we get 3.45 centimeters, another reading we end up getting 3.01 centimeters, okay. Every reading the measurements tend to vary by a large amount, okay. Then we say that particular value is basically random error. And if you see the next quantity, systematic errors, this could be because there's some sort of an error in the instrument itself. For example, let's see you are trying to find then again let's say there could be environmental errors. Let's say like you're trying to measure something with your scale, but the temperature is very the temperature itself is very of that particular room where you're carrying the experiment is actually very high, so the scale tends to expand. So these could come into environmental error. And observational error is basically again when you end up taking values, let's say parallax error could be accounted for observational error. Once again, yes Akshay, thank you for that. And if you see these, again we are not going to go into depth with them because these are quick types of errors, because today we are going to concentrate on how to eliminate errors, okay. Now for example, let's say we have this rod over here, okay. Our idea in this case is to find what is this length of this particular rod, okay. Let's say the actual length, is 3 meters. For example, the actual length is 3 meters. We don't know this, okay, but we are trying to measure it, okay. Now let's say we tend to take 2 readings, okay. First time we measure, okay, let's go with L1, we get the length to be sorry, let's go, yeah, 59. Okay, such a small value. Next time we measure, we tend to get 3.11. Okay, now if you see the errors, the difference itself, every time you measure you're getting a very large difference. Now thank you for that, Akshay. Now if you try to take the mean between these two, L1 plus L2 divided by 2, mean is how many number of observations are there, that is the sum of observation by number of observations, right? There are 2 readings that we have taken and we have to find the sum. So length over here what would happen, it will be 2.59 plus 3.11 divided by 2. So if you find the length, you will get somewhere about 2.85. Now this is sort of close but not actually very close, right? It's not very close to this value. Now let's say we are going to repeat this particular experiment, okay, and we are not just going to stop with 2 readings or 1 reading. We are going to find another 2 more readings, okay, and let's say the next time you found it to be 0.32 and the next time 0.35, right? Now divide by 4, okay. Now because there are 4, you've done the measurement 4 times, so sum of observations, right, by number of observations, how many times you took the reading, 4 times, right? Now if you take the mean, it tends to become somewhere close to 2.95. now last case you got, last case you ended up getting 2.85. now compared to it, you ended up getting more, or you're trying to go very close to this value. So how did we reach this value to be very close to this particular value over here? Okay, that is because you increase the number of observations, right? So the arithmetic mean of all measurements can be taken as the true value of a measuring quantity. If you don't know what is the true value, what we have to do, we are going to take the arithmetic mean. So the number of times you increase the number of times you're doing the experiment, then your value tends to become very small. So here what we have done is basically arithmetic mean. Okay, now there is one more point to be noticed here also. For example, whenever you want to eliminate error, here what was the length we found? 3 meters. Sometimes when you're finding the readings, okay, a last measurement I gave had an error value of very large, right? So in this case, let's say first time you're measuring, you're finding 2.99. Next time you're measuring, you're getting 0.31. Next time you measure, you say 0.98. Next time you're getting 0.32. Now look at the difference between these 2 measurements. Now 3 minus 0.22 ends up giving you 0.01, right? Next value if you subtract, 0.02. Now these 2 values if you subtract, 3 minus 0.01 will end up giving you minus 0.01. Now this will end up giving you these 2 values if you subtract, 3 minus 0.02, you're going to end up getting a negative value, right? So for every positive value, there seems to have a negative value. So the more number of readings you take, so the positives and the negative, there is a possibility of this these values to cancel out each other, and we might end up getting the true value. Okay, so this is one method in which we can eliminate random errors. Okay, now that we know how to find the arithmetic mean, let's do a question, and we are going to learn how to eliminate errors today using one example. Okay, so very simple question. If you have the answer, you can give it in the chat box. Okay, in an experiment, the length of the rod was measured and found to be 3.15 meters, 3.17 meters, 3.14 meters and 3.12 meters. We are going to find the average length of the rod. Okay, so what is the average length of the rod? Now because we are using length of the rod, let me take this as L. Okay, right? So average length of the rod is going to be, let's say this readings is L1, L2, L3 and L4. So we can take this as L1 plus L2 plus L3 plus L4 divided by 4. Right, so complete, what will be the total length over here? 3.15. Yes, Akshay, that is actually the right value. So 3.15 plus 3.17 plus 3.14 plus 3.12 divided by 4. Right, so length over here is basically nothing but, if you add all of these and again if you tend to divide by 2, so you'll get somewhere around 12.58 divided by 4. That tends to give you somewhere around 3.145 meters. Let's round it up to 2 decimal place values, that is 3.15 meters. So that's it, Akshay got that. So here your answer is 3.15 meters. Okay, this is how you find the actual value or the arithmetic mean. Why we are calling it as the actual value is whatever is the mean of, do any observation, okay, for any quantity you want to find the mean of that particular quantity. That will be the actual value of of the quantity you're taking. Okay, to represent it in terms of, you know, in a general representation, here we are going to make use of this alphabet A. So you can take A mean or A bar or A mean, both you can take. Okay, is nothing but A1 plus A2. This is the number of readings by total number of readings. Okay, alright. So this is one part. Now we know how to find the actual value, right? If in any object, okay, if we don't know what is the length of this rod, now doing finding average mean, we have found the actual mean. Now how do we actual value of the rod, right, or the length of the rod? Now how do we find what is the error in it? Okay, so how do we express the error over here? For that, we are going to do a number of steps. Okay, it's very simple. 4 points you need to remember. First case is you are going to find the absolute error. What is absolute error? Very simple. Let me give you one example. Okay, then we will do a numerical. For example, let's take this previous question over here. Okay, or let's say, okay, let's take, because it will be on one slide. Let's say the thickness of the pencil is 3.25 meters. This is actual value. The first reading you took, let's say it is 3.24. The second time you read it, the reading you take, let's say it is 3.26. Okay, let's say this is the value. Now, what is absolute error? Very simple, very simple quantity over here. What we are going to do is, we are going to find absolute error, I am going to take this term as delta T1. Okay, this is going to be, okay, or in other words, let me express all of this in A so I don't confuse. So confuse all of you. So let's say this is A. Okay, now delta A1 if you want to find, okay, this will be nothing but find the mean, okay, minus the first value. What is the mean here? 0.25 minus, what is the value? This is the mean value, right? This is the actual value, minus 0. Thank you Akshay for that. That's the right answer you got. This is basically 0.01 centimeters. Okay, delta A2 will be what? Very simple. This will be 3.25 minus 3.26, which is minus 0.01 centimeters. So the magnitude of difference between, okay, difference between the true value of the quantity and the individual value, that is every measurement you take, what is the individual value, that gives you absolute errors. Okay, if you have any doubt, ask me in the chat box now itself. Next quantity what we are going to see is mean of final absolute errors. Okay, now look at this term we have over here. One is positive, one is negative. When we try to take the mean, they will cancel out each other. But what are we trying to find here? Okay, which means if they cancel out each other, what it means is there is no error. But no, what we are trying to find here is what is the error, right? For that purpose, what we are going to do is we are going to ignore the negative sign and we are going to take the positive magnitude of all the absolute errors. Okay, so when you say we are going to take the positive magnitude, what you are going to do is very simple. We have to find the mean, but mean of absolute errors. Okay, that is, you want to find the mean. Okay, so if you are finding mean in this case, it will be for delta A1 plus delta A2. But one thing to be taken into account is you have to take the positive magnitude. Okay, so in this case, delta A mean will be very simple quantity. Here, what is this? This is nothing but 0.1 centimeters plus, okay, we have to take only the positive quantity, 0.1 centimeters divided by 2. That is again 0.2 divided by 2, which is 0.1 centimeters. Do not add them and cancel them. Okay, so you have to take the positive magnitude. Alright, now, okay, now that you have this, let's quickly do the numerical before we return back. Okay, now same question. In an experiment, the length of the rod was measured and found to be 3.15 meters, 3.17 meters, 3.1114 meters and 3.12 meters. The actual length of the rod was found to be 3.15 meters. Okay, this is the average mean value. We want to find the mean absolute errors. Okay, steps are very simple over here. It's very straightforward also. What would we do? First, let's assign this. Let's take it as L1, L2, L3, L4. This is nothing but L mean. This is the average value, right? So, if you want to find, we want to find what is the absolute error for each and every quantity one first. Okay, so delta L1, this represents absolute error. Okay, find absolute error for each quantity. Okay, so delta L1 in this case will be nothing but in this case it will be nothing but L mean, okay, minus, okay, L1. So delta L1 will be nothing but 3.15 minus 3.15. Here we end up getting 0. Okay, now delta L2 will be what? Very simple over here. Okay, I'll make this the common expression. So delta L2 will be what if I substitute 2 over here? 3.15. Yes, Akshay, you got that, but check what the question is asking you for. Okay, this is minus 3.17, right? This ends up giving us what? We have 3.17, so this will be minus 0.02. Next, delta L3 will be what? What is the mean value minus the measured quantity, right? The measured quantity, third reading is 3.14, which is actually which will actually be end up being 0.01. Okay, and the fourth value, if you take, it is 3.15 minus 3.15 over here, right? This will be 3.12 over here. I'm really sorry, this is basically the fourth reading is 3.12 over here. You'll end up getting 0.03. Okay, now to find what is the mean absolute error. Okay, let's give mean absolute error as delta L mean. If you want to find the mean absolute errors, add all of these quantities, but add them taking only the positive into account. Okay, so this will be 0.02, 0.01, 0.03. This will be 0.06. Okay, actually you got 0.06 correct till that point. Okay, now we have 0.06 divided by, right? Now, how many readings were there? 1, 2, 3, 4. There are 4 readings in total, right? Because we have done the measurement 4 times. So, divide this by 4. Okay. So, if you divide this, you will get somewhere around 0.015 meters. So, let's round this value. Okay, to be somewhere around 0.02 meters. Okay. So, Akshay, check your value once again. So, this should be divided by 4. Check if you divided by 4, not by 3. Okay. So, this tends to give you around 0.02 meters. So, this is one. This is how you find your mean absolute errors. Okay. Now, having found this, you can give your answer in terms of mean absolute errors. Very simple. Find. So, now if you want to find what is the actual length, okay, if you want to express what is the actual length of this particular rod over here, the actual length is, what is mean value over here? That will be the actual value, that is 1.5, okay, plus or minus, because the value that you are finding, right, will always be within a range, okay, plus or minus in this case. What was the absolute term we got? 0.02 meters. This will be in terms of absolute errors, okay. What it means is, the length of the rod is somewhere in the range, it is within the range, within the range, I'm sorry, just a second, yeah, within the range 3.13 meters to 3.17 meters. Okay, you take away 2 from this and add 2 to this. Okay, it's within this range. It could be 3.13, 3.14, or it could be 3.17. This gives you your absolute error. So there you go. So we have found what is absolute error. We have found what is mean absolute errors. Now, other than absolute error, you can express the quantity in terms of relative error. Okay, relative error is very simple. Let's say you found mean absolute error. Okay, so let's give that by the term, let's say the mean absolute error is delta A mean. Okay, now relative error is very, very simple. Okay, so relative error will be what is the ratio between, okay, you take the mean absolute error, this is the final mean absolute error, okay, divide this by what is the mean or the actual value of that particular reading. Okay, that will give you relative error expressed in the terms of delta A. Okay, this will give you relative error. One more term we have. Now we know how to give it in terms of absolute error, how to give it in terms of relative errors. Now from there, in case if you want to see what is the percentage error, okay, from here you can actually do that. Okay, so from percentage error, if you actually look at, very simple, find what is relative error, delta A, right, multiply by it with 100%. So here what you get, whatever is the mean value, find absolute final or mean absolute error, divide it by the actual or the mean value into 100%. That's it. That is basically percentage error. Okay, very simple. Alright, So let's try to do the same numerical. Let's extend this. Okay, same numerical, we are extending it. Don't worry, all the quantities you require are in the question itself. Okay, in an experiment again, the length of the rod was measured and the average length was found to be 3.15 meters. We did that as first part. And the mean absolute error, what was the mean absolute error we found? It was found to be 0.02 meters. We want to calculate percentage error. If you want to express in percentage error, you have to find relative error. Okay, so how do we do that? For here, let me take in this, because it is length, relative error for length is nothing but, okay, what is the absolute mean value I have taken for this particular length, okay, and what is the mean value, okay, this will give me percentage error. Okay, so this is nothing but 0.02. This is the absolute error, mean absolute error. This value gives us the mean absolute error. Then the average length, that is nothing but the actual or the arithmetic mean of this particular rod, right? That is, the experiment has been repeated a number of times and a value has been found. Okay, this is 1.15. Okay, now this value, if you divide by, okay, you will get the answer for relative error, or another word for relative error is percentage error. But we don't want percentage error. We want to express this in terms of, okay, in terms of, we don't want relative error, we want to express in terms of percentage error. If only relative error is asked, stop over here, okay. So solve this, you will end up getting 0.006349 and so on. So with this the answer comes to an end. But if they are asking you for percentage error, you have to multiply this quantity by 100. So you have 0.02 divided by 3.15 into 100, okay, 100 percentage, okay. Yes, Akshay, thank you for that. If you see, you will actually get the value to be 0.6. If you solve for this, you will end up getting the answer as 0.634920 percentage. We can round this off to 2 decimal values. It will be 0.63 percentage. That is the percentage error. Now again, there are two ways. Now we can express this answer in terms of percentage error. Okay, very simple. Okay, in case if they are asking you to express in terms of percentage error, one thing you will do is first you write what is the actual value. Actual value is what? 3.15. This is arithmetic mean. Okay, plus or minus what was the percentage change? That is 0.63 percentage. Write the units outside. Okay, this gives you, this is how you express an answer in terms of percentage error. Alright, so once again, if you have any doubts right now, ask me in the chat box. So to sum up, first step when you're eliminating error is that, first step, find what is the average, what is the mean of this particular value. That gives you the actual value. Okay, then if you want to find what is the error, right, we found the mean, so we found the actual value. Now we have to find the error. Now from each and every reading you got, eliminate, okay, subtract mean value from individual reading. Okay, the values could be 0, positive or negative. So the next step, what you have to do, you have to find mean of this absolute error. When you do that, make sure you take the modulus, that is, you're taking only the positive magnitude. Do not subtract the positive and the negative values. We're trying to find errors, so we have to take, even if you get a negative term, you have to take the positive term for it. Okay, alright, so we take the positive magnitude of all those quantities. Okay, and similar to how we found the mean, the absolute error, how many number quantities are there, find the mean for that. Next, we want to give it in terms of, in case answer is asked only till here, you can stop, but in case if they ask for relative error, very simple. Okay, take mean absolute error that you got, divide it by the mean value, whatever is the mean value, that will give you relative error. Percentage error is very simple, find relative error, another name is fractional error. Okay, find that because you are taking it in terms of a fraction, right? Relative error, if you see the same, another word is fractional error, right? So you take that into 100 percentage, that will give you the percentage error. And expressing this answer is very simple. You always go with the actual value plus or minus the error value. Okay, that's how you always give the answer. Now with this note, this is just part 1 of today's class. Okay, but don't worry, we will be doing one numerical before we end the session. And next class we will be doing part 2, that is, in case if there is combination of errors, what would happen. So before we end the class, let's do one more experiment, but in the interest of time I have taken only 3 readings. Okay, So in successive experiment, the reading of the period of oscillation of a simple pendulum were found to be 1.50 seconds, 1.48 seconds, 1.51 seconds in an experiment. We want to calculate the mean value of the period of oscillation and express the result in terms of percentage error, which means we have to find mean value, right? Which means first we have to find mean value, okay? After we find mean, we have to find absolute error, then we have to find mean or final absolute error, then find relative error and express it in terms of percentage error. Okay, these are all the steps we are going to follow over here. Okay, now let's see, let me try to do partly over here. Okay, so here first thing we are going to do is, first value we'll try to find is, because it's time period, let me give this a value. Let's say this is T1, this is T2, this is T3. That is the first time you did the experiment and found the values. Okay, second and the third time you did the experiment to find the values. Now, what is mean value? Okay, that is time period. What is the mean of the time period? That will be T1 plus T2 plus T3 divided by 3. Right? So, mean value over here will be what? Very simple. It will be 1.50 plus 1.48 plus 1.51 divided by 3. Okay, so mean value over here is again equal to 4.49 divided by 3, and we'll get 4.949, and the 6 tends to be a recurring digit, like you will end up getting 1.49666. okay, so the 6 tends to be a recurring digit over here. Okay, but we don't want to take such a long value. We will, because the answer is again only given up to 1 decimal place value, but it's okay. We will take up to 2 decimal and then finally round it off. Okay, so or we can actually go with just 1 decimal, because they are asking only up to 1 decimal. So if you round it off, I'll get somewhere around 1.50, right? This seconds. This is the mean value, right? Okay, so from here we can see one option is out. So, what are the first part of the question? What is basically the first part of the question here? First part is calculate mean of period of oscillation. That is nothing but time period mean. We found this value. Okay, first part of the question we are done. Now, next is we want to find the error and express it in percentage. Okay, so what I'm going to do, let me do this separately. If you want the answer, you can always go 5-10 seconds earlier to find the answer, right? Let me do this separately over here. So, the first part, okay. What we want to do is basically, okay, let's say I want to find what is the mean value, right? Sorry, I want to find what is absolute error, right? Let me quickly write down the values I have till now. I know T1 value is 1.50, T2 is basically 1.48, and T3 is actually 1.51. And I found mean value, mean time period to be 1.50. Now, if I find absolute value delta T1, that will be what is mean value, that is 1.50 minus individual value. In other words, if I want to find what is the mean value, okay, mean value, that is absolute error in terms of mean, it will be what is the mean value for time period you got minus the individual value. Okay, minus individual value, where n could be 1, 2 or 3. So, T1 in this case, okay. Let's say, okay, I'm sorry, absolute errors, right? Individual terms we want to find. So, let's say I'll write it as delta Tn. So, T1 is nothing but 1.50 minus T1. Minus T1 is 1.50. This is 0. Now, delta T2 over here is actually 1.50 minus 1.48, which is nothing but 0. Okay, actually just check your value once again for absolute error. Absolute error, fine. Yeah, yes, actually absolute error is fine. Try to find mean absolute error, right? This will be somewhere around 0.02. Now, delta T3 is nothing but 1.50 minus 1.51. Obviously, this is 0.01. Now, what is absolute error in this case? Okay, absolute error, we'll take it as delta Tn. So, this is basically negative, but always remember, we are going to take absolute value. So, we are going to add all the terms. So, this will be 0.03. Now, mean absolute value. Okay, if you want to find the mean absolute value, okay, what we are going to do? We are going to take all of this quantities individual values. That is, you are going to take 0. Then you are going to take 0.02. Then you have to take the positive value for 0.01. That is 0.03. Okay, so you only have to take the positive value for each and every case you have over here. Okay. and so that's nothing but 0.03 divided by 3. So that ends up being 0.01. Thank you, Akshay. That is mean absolute error. Okay, so from here you can give the answer as 1.5 being the mean value. Okay, 50 plus or minus, because we are giving up to 2 decimal place values, 0.01 seconds. In case if the question asked is basically for in case if it is basically with with absolute error, but we want to express in terms of percentage error. If you want to express it in terms of percentage error, what you will do? You have to take a ratio between this quantity and this quantity. Mean absolute value by absolute value. Okay, so percentage error we want to express, and let me give it in terms of just one single step. Okay, percentage error is nothing but absolute error. This is absolute error times percentage, right? 100%. So what is absolute error here? Absolute error is nothing but delta t mean. This is basically mean absolute value by mean value, right? I'm sorry, this is not delta t, by mean value. This will be t mean. Okay, into 100%. Let's directly substitute to it. So this will be 0.01 divided by 0.01 divided by in this case it will be somewhere around 1.50 into 100 percentage. If you solve for this, you will get somewhere around 0.666, and it keeps on going. So this is 0.66666, right? This will tend to recur. Okay, there's so many percentage. We can actually give it in terms of one single percentage over here. Okay, we can rearrange this, basically give it in terms of we can give it in terms of 0.6 is not in the answer, right? 0.6 is not in the answer, so we can actually round it up. So because it is greater, right? So you can give it as 0.7%, right? So that's percentage error is 0.7. So how would you express it? You express it as an actual value plus the percentage error, plus or minus the percentage error. So option number C is the answer. Okay, yes, actually option C is the final answer. Okay, so so these are the steps. So once again to recall, okay, what is the first steps you will do? First, find actual value, that is the average mean. Then find individual quantities separate from the individually readings you have subtracted from the mean value, that is your absolute error. Now take the mean of this particular, try and take the mean of this particular absolute error, that is mean absolute error. Finally what you do? Take a fraction. Fractional error is nothing but take a ratio between your mean absolute error and the actual value of the quantity, that is the average of this particular the mean of this particular measurement you've taken. Okay, that will give you relative error. Now multiply it by 100%, that's it, percentage error. You always express the error in terms of actual value plus or minus, either in percentage error or in terms of absolute or relative error, however the question is asked. Okay, so with this note I am coming towards the end of today's class. Once again, if you have any doubts you can ask me right now. Now what you can do is go down to the description box. There would be link, that is basically there would be link for the upcoming special classes that are happening on the platform, and you can actually go and enroll for these particular classes, and those special classes are absolutely free. And you can also search them using my code. Okay, you can actually search them using the educator code as well, MTIS10. Okay, and you'll be able to find these courses and you can enroll for them. Okay, and also part 2 of the course we will do upcoming in the coming week itself. We will do part 2 of error analysis, where we learn how, when there is a combination, right, when there are two terms getting added, two terms that we are subtracting, okay, when there is combination, how to eliminate errors. Okay, that's what we are going to see. So make sure if you like the video to subscribe to the channel, like the video and share it among your friends, and also subscribe to the channel and click on the bell icon so you get notification before any classes goes live. Alright, I'll see you all in